Right, hello everybody. Quick run through of the breadth mock that you have just done. Okay, so I'll go through the multiple choice questions and then the extended questions. Question one, quickly running down these, which of the following statements is true about group 2? They form ions by loss of electrons from a p subshell. Obviously not, because they're in the s block. How could they release oxygen when there is no oxygen to release? They get more reactive as you go down the group, so obviously they're not more difficult to ionize, so the answer is D. They increase in oxidation number when reacted with oxygen. E-theme, okay, you're asked about the structure and which statement is true, you're being asked for, okay. Sigma and pi bonds, yes there are, and then the rest of them obviously are going to be no. So as soon as you see that that one is the correct answer, you should really be looking. The last one there is obviously to fool you because it's nucleophilic addition, whereas it's actually electrophilic addition in an alkene. You're given a skeletal formula of this particular compound and then asked what's true about it. So obviously, you have to know some of these things. I mean, EZ isomerism, can it show EZ isomerism? No, because the double bond is at the end of the molecule, and that means it will have two hydrogens. If there are two of the same group on one of the carbons with the double bond, then it cannot exhibit EZ isomerism. Can it undergo addition polymerization? Yes, it can. It would have to be a primary alcohol if it was going to give an aldehyde, and this is a secondary alcohol. And there are other bond angles other than 109.5 around the trigonal planar carbon that has the double bond. Okay, yeah, this one you've got to recognize that the biggest change in ionization energy in an atom is going to be when you're moving from one shell to another. With aluminium, it's in group 3, so you need to remove 3 electrons, and then there'll be a big jump as you move in to the next shell, so between the 3rd and the 4th, because every time you remove an electron, don't forget, it becomes more difficult to remove the electron, and obviously once you've removed a whole shell, it becomes kind of doubly difficult. Okay, so you're given an ion here, it's got 3- charge, you're given the atomic number, you're given the mass number. Quickly go through, this is knowing the structure of atoms, clearly understanding the structure of atoms. Obviously it doesn't have 31 protons in it, doesn't have 31 neutrons in it, doesn't have 16 protons in it. Could be found in the compound magnesium, I don't know what that would be, phosphide. If this is 3-, magnesium is 2+, then obviously the formula would not be MgP. So it's got the same number of electrons as an argon atom, because 15 here, we've lost we've gained 3 electrons, haven't we? Which is, so that's quite true. It's got 18 electrons. Okay, what is not true about the reaction? So be careful with these questions when they're saying not true. It's very easy because the first thing you see is something that is true and you think that must be the right answer and you scribble that down. The question is asking you what isn't true about the reaction between ethane and Cl2, and you have to recognize that this is a radical substitution and happens when there is homolytic fission between the bonds, okay, where we form radicals. So that's definitely incorrect. The rest of them are all true. Problem is, if you haven't recognised that is a radical substitution reaction, yeah, so you're not thinking about what goes on. Question 7, we've got methyl propane 2-ol, so we've got a tertiary alcohol here, yeah. Okay. Series of statements, and you're asked which one is correct. Yeah. So we what does this say? Acidify to form only one alkene. Okay, so if we're forming an alkene, we don't use potassium dichromate, we use concentrated acid. Obviously, you have to learn these reagents and conditions, and this is where your synthesis map will help. If you learn that, then you would know that that was the case. We can't be forming 3 different alkenes here anyway, because we've only got one OH group, and there's only possibility of 2 different places where the double bond could go, so we're not going to get 3 different alkenes. So the answer is B. Okay, an alkene contains 8 hydrogen atoms. Which one of the following statements is correct? So it's got 8 hydrogen atoms, it's an alkene, it must have 4 carbons. Okay, and we're looking for what is equal to its empirical formula. Yeah, so you're looking for the lowest whole number ratio. Yeah, so then you just go through the statements, and a molecular formula that is 4 times multiple of the empirical formula. Yeah. If you don't know what empirical formula is, the definition of empirical formula, you will struggle answering that question. Number 9, okay, mass spectrum. Which of the following peaks would not be seen in the mass spectrum of methanol? So if you draw methanol out, you can see possibilities where it can break. Yeah. So it says that we could find a peak of 17 because of the oxygen and hydrogen. Peak of 32, that would be your molecular iron. Peak of 33 is impossible because the total molecular mass is only 32. So if you look, you can't get a peak at 16 because you'd have your oxygen and your hydrogen, which would be 17, or you would have a break here, maybe carbon plus hydrogen plus hydrogen plus hydrogen would be 15. Yeah, so 16 is an impossibility. How many moles of aluminium ions are present in 200 cubic centimeters of 0.6 moles of aluminium sulfate? So here, straight away you should recognize there are 2 moles of aluminium ions for every 1 mole of aluminium sulfate. And if you don't see that, then you will get that wrong. Okay, because you calculate it as 0.12, and then you have to multiply it by 2. Because there are 2 moles for every 1 mole of aluminium sulfate. Okay, which one of the following reactions is the enthalpy change equal to the bond enthalpy of an HF bond? So you have to be breaking the HF bond. So HF going to H and F, that is when that bond has been broken. Not when you're forming ions, yeah? Or, I don't know, basically, to me, it's pretty straightforward. If you're looking for the bond enthalpy of that bond, HF, that's the answer, A. Okay, we're given an equilibrium and given some information about Kc and the equilibrium concentration of this gas, N2O4. And then asked about the equilibrium concentration of the other gas. Yeah, so we are looking at writing out the expression for Kc and then quickly calculating it. Yeah, so you're looking for this, you know that, and you know that. So you rearrange the equation. Obviously, you need to recognize that if NO2 is squared, and that's the concentration we want, we need to find the square root of the other side of the equation, and that will then give us the equivalent of what has been squared. So there you are, I've done the calculation. Number 13, which one of the following is the correct explanation for an exothermic reaction? So those two statements are nothing to do with anything to do with explaining an exothermic reaction. So basically you've got to work out here which is the correct statement. So this one, if more energy is given out during bond breaking and is taken in during bond forming, and so obviously that is, when we break a bond, energy is taken in. Yeah, so the answer has to be D. More energy is given out during bond formation than is taken in during bond breaking. Yeah, because this is the endothermic process as we break the bonds. This is the exothermic process as we make the bonds. Remember that. Okay, iodide ions, there's some statements that follow. We have to find the correct one. Okay, so basically, are they more easily oxidized than chloride ions? Will they lose electrons easier than Cl minus? Yes, they will, won't they? Because you've got that extra shell of electrons, you've got shielding there. So the outer electrons make it easier to lose them. So the answer is A straight away. This one you just quickly got to run through and work out the oxidation number, and obviously this one comes out to +3. So if you're not sure on calculating oxidation numbers, now's the time to practice and make sure you do know what you're doing. Equilibrium here for ammonia. I mean, that equilibrium sign should be over here, obviously. Okay, and we are asked, what occurs when a dynamic equilibrium is set up? So the concentration of reactions and products are always equal. That is definitely not true. They are constant. They are not equal. Addition of a catalyst increases the amount of product. No, it doesn't change anything to do with the equilibrium. It just increases the rate. Yeah. Only a change in pressure affects the position of equilibrium. That is not true, because obviously if we change the temperature, that will also affect the rate of equilibrium, or if we change the concentration of one side. So the last statement, the rate of the forward reaction equals the rate of the backward reaction, is correct. This one, you need to learn these terms: aromatic, aliphatic, alicyclic. You need to know the difference between them. This is definitely not aromatic. It doesn't have a ring in the middle, or it doesn't have 3 double bonds, depending on how they represent it. So it's not aromatic. It's not aliphatic, because aliphatic has to be a chain. Is it saturated? No, there's a double bond in there. So it's alicyclic. Basically, it's formed a ring, but it's not an aromatic ring. Given hydrogen bromide here, you're given the reaction between hydrogen bromide and propene. You're asked about that, and you're asked how does it proceed. So does it go via a tertiary carbonium ion or carbocation? It can't do, because this carbon would be secondary carbocation. This carbon would be a primary carbocation. Make sure you know the difference. Make sure you know how to define primary, secondary, tertiary, carbocation, and anything else that has that classification. Would it produce 2-bromopropane as the main product? Yes, it would, because the secondary carbocation is more stable than the primary carbocation. So yes, that's true. Is it an example of electrophilic addition? Yes, it is, because hydrogen bromide is attracted to these electrons here, and it adds across this double bond, so we only have one product. So your answer is 2 and 3 are correct, not 1. Okay, in the contact process, I've given another equilibrium here. and again given a series of statements and asked to work out which ones apply. So is the atom economy 100%? No, it isn't, obviously. This is an equilibrium anyway, so it's constantly changing. The percentage yield cannot be 100%, which is always the case. You're never going to get 100% percentage yield. The percentage of sorry, hang on a minute. Right, sorry about that. A blip there. I misread that. The percentage yield cannot be 100%. That is always true of any reaction. Okay. So atom economy is definitely not 100%. Percentage yield cannot be 100%, so that is true. The percentage of SO3 in the mixture can be increased by reducing the pressure. Would that happen? There are less moles on this side. So if we decrease the pressure, which is reducing the pressure, we will push the equilibrium to the side with more moles. Okay, so no, that is not true. So the answer is B. Okay, so we yeah, okay, off we go. And question 20. Sulfur contains S8 and has a higher melting point than phosphorus, which contains P4. The higher melting point of sulfur compared to phosphorus is explained by these following statements, and again you've got to pick out whether it's all of them or one of them or two of them. The higher melting point of sulfur, okay, so the dominating intermolecular force here are the S8. S8 are bigger molecules, you've got more electrons, so it's London forces, yeah. So the higher melting point of sulfur compared to phosphorus is explained by sulfur having stronger London forces between its molecules. Yeah, that is true. Having stronger covalent bonds between its atoms, that is not relevant. And having stronger permanent dipole-dipole attractions between its molecules is not relevant. So it's only one is the correct answer. Okay, so that's the end of the multiple choice questions. I think actually what I'm going to do another video to look at the extended questions, because this is a 20-minute, nearly 20-minute video as it is. Okay, bye.